My name is Father. Me and my group member we are here to talk about a particular topic, which is called sequence of the real number. Now, what does sequence of mean? This is the function that asks the domain to go to a natural number. And it's the domain to go to the real number. And it is generally described as this. That is where all n is coming from a set of natural number. Now, I'm talking about a particular aspect of it, which is multiplicity of the sequence. What does it mean? Multiplicity of the sequence simply means the sequence is either increasing or decreasing in order. We want to specify, we want to know maybe the sequence given to us is either what increasing or decreasing. Different methods to verify this out. The first one is what? Difference in terms of sequences. If the next term or the second term in a particular sequence, you subtract the first term from it and it's bigger than or equal to 0, that is what is increasing. The second one is what? Is quotient. That is, if second term divided by the first term is what? Is greater than or equal to 1. That is what? Is under increasing. Then the third one is what? Is what we call calculus method. Which means, if our given sequence, if we differentiate it one time, and we now, for all values of our x, for all value of x coming from natural number, for all value of x coming from natural number, if we put it in that given function, and it is what? Is greater than or equals to 0, that's what is giving us increasing in order, and this one is what? Is the decreasing value. Now, so using this example to verify whether this particular sequence is what? Is increasing or decreasing in tonicity. Now, let's take, we have our an equals to n all over 1%. We have an equals to n plus 1. This is going to be our next term in the sequence, which is equals to this. We just input this value, n plus 1, we input it here, we take this multiply n. Just like that, we have n plus 1 over n plus 2. Now, taking the difference, we are using this first method to verify maybe this is increasing or decreasing in value. So we have n plus 1 divided by n plus 2 minus n over 1 plus n. After simplifying this, we get this, which is what? 1 divided by n plus 2 and into what? 1 plus n.
And that's perfect.
So, getting this, we have 1 divided by n plus 2, then into what? 1 plus n. It's telling us that all values of n, starting from, taking it from what? Set of natural number. There is no value of n that we put here that will give us what? Any number less than what? 0. Or that will give us any number that will be equal to what? Equal to 0. That is telling us that it is strictly monotone increasing. Thank you very much.
Hello my people, my name is Ajayola Odua and I will talk about convergence of the sequence. The sequence dey converge, it means say as we dey go far for the sequence, as n dey big, the numbers go dey near one fixed value. That fixed value na the limit of the sequence. For example, if you look the sequence an is equals to 1 over n, as n go dey go like 1, 2, 3, the terms go dey reduce. It means say our 1 over n go dey like 1, 1 over 2, 1 over 3, 1 over 4. The numbers go dey near 0 as n dey big. You understand? Make we look another example. Make we look an is equals to 1 minus 1 over n. When n dey equals to 1, you go see say 1 minus 1 go equals to 0. 1 minus 1 over 2, when n na 2, 8 go give us 0.5. And when we consider that, we go reach when n dey equals to 5. 1 minus 1 over 5 will equals to 0.8. So at n dey big, an will be close to 1. Mathematics dey talk say for sequence to converge, at n dey big, we fit control how near the sequence go dey to one fixed value n, which we go call the limit. For any small number epsilon, we go fit find one position n for the sequence. So then if small n go big pass or equals to n, the gap wey dey between the sequence term and the limit go small pass epsilon. Mathematically, as we dey find the absolute value an minus l, which be our limit, wey dey less than epsilon, this na just to talk say as e dey go, the terms go dey stay close to l.
Hello, my name is Suleiman Ali. I am here to go on the topic my partner just talked about, convergence of the sequence. In my case, it's the convergence. What exactly is the divergence of the sequence? It refers to the behavior of the sequence of real numbers, an, as long as n tends to infinity. when it does not approach a finite limit. In other words, the sequence does not set on the value, it goes on and on. Now, there are multiple definitions of divergence, such that one of them is when it does not converge to a real number L. From my partner's statement, we can take that L can be the fixed value, which is the limit. Now, for every real number L, they exist such that the epsilon is greater than 0. No matter how large n is, they exist n greater than n, such that the absolute value of an minus L is always greater than or equals to epsilon. Another one is it may tend to infinity. That is, when the limit of a real number as n tends to infinity is equal to infinity, every n is greater than 0. There exists n, which is a natural number that is greater than 0, such that real number an is greater than n for all n greater than natural numbers. There are multiple examples of divergence. I will probably just mention 3: oscillatory divergence, unbounded divergence, and undefined limits. I'll talk about unbounded divergence. It is a sequence that goes without return. For example, we have the an is equal to n, or an is equal to minus 1 raised to the power n. Undefined limits, as another example of divergence, is a limit that has no trend or a sequence that has no trend or limit. For example, an is equal to n sine n. It fluctuates value because n tends to infinity. Note, divergence is, like I said earlier, a sequence that does not converge in any value and doesn't have a final value, which means it always goes. Thank you.
Hello everyone, my name is Joe and I'll be talking about boundedness of a sequence. The boundedness of a sequence refers to whether a sequence of number remains within the certain limits. I need to say, meaning it does not grow within the arbitrarily large, that is, it does not grow arbitrarily large or small. A sequence is an is bounded if there exists a real number m greater than 0, such that the absolute value of an is less than or equals to m. That is, for all n in elements of a natural number. In simpler terms, all the terms of the sequence within lies within this interval minus m and m. A set E in real number is bounded below if there is a real number m called a lower bound of E such that m is less than or equals to x for all number x in element E. A set E in real number is bounded below if there is a real number m called an upper bound of E such that x is less than or equals to m for all x in E. So that is for the upper bound and the lower bound. So for the both bound, we have if the sequence is both upper and lower bounded, it is simply bounded. That is, if the sequence lies between the both, the upper and the lower bound, it is simply bounded from above and below. So for example, here we say prove the sequence of an, which is equals to 1 over n, is bounded. So we start from the definition. That is, an is equals to 1 over n, where n is greater than or equals to 1. That is, the absolute value of an is equals to 1, the absolute value of 1 over n, which is equals to 1 over n, since n is greater than 0. So for the inequality, for all n greater than or equals to 1, we know that 1 over n is less than or equals to 1. That is, therefore, the absolute value of an is less than or equals to 1. For number 4, we have the bound. We say let m be equals to 1, then the absolute value of an lesser than or equals to m is equals to 1 for all n greater than or equals to 1. This shows the sequence is bounded by n is equals to 1. The sequence an equals to 1 over n is bounded because its terms are always between 0 and 1. And that is the proof to show that, to prove the sequence of an equals to 1 over n is bounded. Thank you.